Awesome. I think we can get started. Super awesome. Folks, thanks a lot for joining another session at Applied AI. If you're, I mean, most of the faces are familiar, but if you're new to this, a little bit of introduction about what we do over here. See, Applied AI is, a close community for mainly for operators, builders, and product managers to learn and adapt to this new AI world, right? Ignoring all the fancy terms, what we simply do is we take specific concepts around using this AI technology, everything from tools to protocols to the whole gambit. We get experts who actually teach us how to work with this ecosystem, right? So that's essentially what we do. In terms of programs, we do a couple of things. Number one is we do these weekly sessions. So every Saturday, almost every Saturday, so we have one expert coming and teaching us a specific concept around AI. Today is one of those sessions. So all these sessions are free. These sessions will be recorded, and all the past sessions you can see on YouTube, and those are also free. The second thing we do is we run these study groups. So study groups is kind of like a self-learning study groups where a group of people come together. They make some financial commitment, like $500, and they learn a concept together. Like the two study groups we have run several times now. One is learning and working with N8, and the second one is vibe coding. So what is they go through this program, they learn, build a project by themselves, and they present by end of 3 to 4 weeks, right? These sessions are also there on YouTube. Some amazing stuff my folks have actually built. Yeah, so that's the second thing that we do. Apart from this, we also have a WhatsApp group. We have about like 450 people over there. I don't remember, probably 400 to 450. And, so we use that for general communication, knowledge sharing, etc. Right. So this is essentially what we do. Yeah. So today is one of our expert sessions. So before I introduce Pawan, a little bit of housekeeping. The session is going, I expect it to be dense given how last session of Pawan's actually was. So please reserve your questions and put them in the chat. Right. So whenever Pawan is able to take questions, we'll actually pick them up from the chat, and towards the end we'll allocate some time for Q&A for sure. Okay. So with that out of the way, I'm very, very glad to have Pawan again as for one of our sessions. So the last time Pawan came about like 6-7 months ago for teaching us a couple of sessions on RAG, one of the best, extremely high dense sessions, like one of the most referred sessions in our YouTube videos also. And this is something that I actually personally go to whenever I want to do something around RAG. I'm very glad to have him again for our session on Evals. So Pawan has been, like, if you have not followed Pawan on LinkedIn, you should definitely do. He keeps publishing a lot of interesting approaches around RAG, and he does a lot of research activities around this particular space. So currently he's a distinguished AI architect at Equal AI. But he has done, like last time we actually spoke, he was working at Outcom, and he's done like plenty of interest, and he's been like with the AI LLM space for a while now, and one of the best research personnel for you guys all to follow, right? So yeah, Pawan, I think welcome to the club again. Probably I butchered your intro a little bit, so feel free to share something else that people would be interested in, and over to you.
I think like you have pretty much touched everything, and thanks that I just came to know that like it's the most viewed video in YouTube on RAG. Okay, so with that, maybe like keeping the standards always at a top notch is like tougher thing. I don't know if you all people still referring to the RAG, and then if we meet that standard of RAG. I'll try my best to keep this eval session also onto the par with that RAG session. So myself session, as Bala says, like I do a lot of research. Of course, I'm a research scholar at IIIT in the LLM space itself. So since it is there in the DNA, so I do a lot of things, and then I keep publishing the articles for free in Medium. So open source is the only thing that actually gives a lot of knowledge for all of us. So keeping that in mind, like I push many things as open source. Like you also can actually fork a couple of my projects and then keep reading the articles and contributing back to the community. So okay, I think like we are good to go, right, Bala?
Yeah.
Okay, fine, perfect. So with that, let me share the screen and then start. Just a second. Sorry, just a sec. Too many screens actually, so. So before I start, just let me give one small caution is like I don't have any fancy PPTs. So I'll put everything what I work in day-to-day life. I put everything on my draw.io boards. I keep experimenting here. So same thing I'll present you so that it will be more easy for both of us, right? Since we are all developers, I think you can also gel along with me. Okay, so just let me know if you're seeing a little smaller fonts or something like that. I can increment them and then we'll have a clear visibility. Okay, so okay, so here is how we go with the agenda today. So I'll teach very less of theory, and we'll see an one end-to-end RAG pipeline, and I'll explain you every part of that RAG pipeline and then hook that with the evals and how many different kinds of evals would come into picture, that we'll see. At the same time, we'll see every eval maybe from a novice perspective. That means like if you are just remember for now is like if we are actually talking from a context relevancy. Okay, so we'll see how context relevancy is computed from a math perspective as a separate concept, but we'll also put that into RAG pipeline and then we'll see how it works in the real time. I don't know how many of you seen, like there is one new paper that is coming into picture. Morning 7 o'clock, I was reading that. So it's from University of Amsterdam. So they say they did something on this evals. So I'll even tell that. I don't have the paper link, but still I'll tell you that, and then you can go and then read after this session. Okay, and then we'll also see agents, and then a couple of methods on agents, evaluation methods when I say that. And then when you come to agent, like agents can be of two types, right? Like conversational agents and non-conversational agents. So there are two different methods to evaluate all these things. And many things these days in LLM, applied AI or applied Gen AI is like you have memory concept, you have DB concepts, you have session concepts. Like too many things have got evolved in the last 3.5 years. So you can develop your own custom methodologies, and there are some defined methodologies by this time, like 3 years, like people has done predominant research and they kept, okay, these are the fundamental things you need to follow, and maybe after that, according to your business case, you can actually do it. So maybe I, out of my experience and what I've done in my own org, that also I'll tell you. Okay, and with that intro or the agenda, so let's see this. Now evals are of like majorly can be classified as three, like prompt evals, RAG and bot evals, and then agents evals. Okay, why prompt evals? Because for everything, right, like rags and then rags and bots, why I combined is because like whenever you start chatting, it predominantly hooks towards rag only, most of the use cases. Okay, so so for rag and agent, the backbone to tell what to do, what not to do is your prompt. So first you have to evaluate your prompt, and to make that prompt more robust and reliable, you need to write some kind of evals around that prompt, how it is behaving, what kind of behavior, if you tune that prompt, what is happening, what not to happen. So all these things like prompt evals. Then as I said, like rag, I'll tell you, and then the agents. Okay, so here is it goes like to evaluate. We need to have the ground truth data sets basically, right? So on the same point, the paper that I was telling you from the University of Amsterdam, they have released it. So data sets again can be of two things, right? You have the exact data set from the subject matter expertise, SMEs from a particular domain. Example, if you take maybe like medical. So if you have a case histories, right? Like you have a very good case histories. If you are working along with medical practitioners, you may collect it from the historical times. Like you can have a very good data set. Like if this is the case, what is the treatment? What is the outcome? This kind of ground truth data set you can actually create. And if you are in a legal domain, so there also, if this is the case, what is the judgment according to this? Like what is the trial happen? So very good data set you can create. Simultaneously, if you don't have it, but still if you want to start from the base and then scratch, and then you can start building it nuts and bolts, one thing that comes into picture is synthetic data set, right? You create a synthetic data set and then prove that your concept is working, then hook it to the actual data set and then work it. So that is where exactly the paper stands. Like if the synthetic data sets are good to evaluate your RAG pipeline, that's even the title of the paper also. Okay, which pulled me in the morning, and I was reading it, and then that somehow coincidentally matched with our session also today. So I'll tell the outcome at the end, but that's how it is. So data sets, you have two. You have the actual ground truth data set versus the synthetic data set. And again, these data sets can be classified as two: singleton and multi-turn. What exactly these are? Like singleton is basically, if you just imagine your RAG, right? So you ask a question, you get an answer. That's called a singleton. And if you are not satisfied, you ask one more question, you get an answer back. So this question answer is always treated as singleton, because there is sometimes there may be a contextual ingestion back, or sometimes it may not be a contextual ingestion at that moment in time. But multi-turn conversations are something like this. You have voice agents, right? You keep on conversating, and there is content, and there is something called VAD comes into. VAD is not there with the singleton. But in multi-turn, you have something called VAD. VAD is voice activity detection. Okay, your agent starts explaining, but you interrupt, and then you start pitching it. So these are called multi-turn. How many times a turn has been shifted? So these all should be calculated. So predominantly, your data set should be of two kinds. Like either it is a singleton or a multi-turn conversational data set.
Pawan,
So,
sorry,
yeah.
interrupt from time to time. So one of the questions I had is working on a customer support use case. Assuming singleton is a good analogy for how I work with tickets coming from customers, and multi-turn is chat plus voice. Is there a good way to think about this?
Yes, absolutely, absolutely. Multi-turn is like you can have a hybrid mixture of both of these things. Yes, and then singleton is, it's very specific. Like you know what to ask, and you are expecting something that you come out. I mean, like your AI agent will answer you. So those are like singleton. Yes, it's you can actually put that into the bucket. Okay, so now since we have understanding on like how the evals, I mean like how the evals can be done on different categories and what should be the base of it, now comes the first use case of it. So I'm not touching on the bot aspect of it, but let's see how the RAG, and then of course in practice we will see it anyhow. RAG predominantly has two different components. Like these are the major contributors of RAG. Of course, there is something at a very thin layer called the augmentation layer, but that is like can be ignored for now. Okay, so retrieval and then the generation. Okay, and the evaluation should be done for these two things, both. So there are perfect methods and some standard methods which can do the evaluations for retrieval phase and the generation phase. One such example is answer relevancy. Okay, answer relevancy is from a generation perspective. If you have an answer from an LLM and then you have an answer maybe as a ground truth, you already know that. So now how much relevant these two answers are. Okay, so this is the answer relevancy. And there is something called faithfulness. Again, this is from a generation perspective. how best your answer is actually sufficing the need of user query, that is faithfulness. Okay, and then retrieval. This is most complex, critical. Till date, it's been 2.5 years. The RAG has been invented, and no standard way. Still, people struggle, and no one actually reached 90% till date in production systems. Of course, POCs, toy datasets, everyone has attained that levels, but at least in the production grade systems, I never saw someone actually claim that they have achieved 93, 94 or something like that. People are around like 75s to 80s, 88s. Okay, so in retrieval, multiple things. Context relevancy is the most complex one. Like when you do a context relevancy, so when an LLM generates an answer and you infuse a context to get this particular answer, what is the relevancy of this context to the generated answer? That's called a context relevancy. Okay, and then you have something called context recall, if I'm not wrong. Okay, so these are like some standard metrics in retrieval phase versus the generation phase, and then you do have to evaluate all these things. And the paper that I'm reading in the morning, they say that your synthetic data sets are good for making your RAG pipeline stabilized from a retrieval perspective, but your synthetic data sets may not help you from a generation perspective. That's what is the bottom line argument of that particular paper was. Maybe, and then after reading through that, like I felt like, yeah, this is good. Somehow I also missed it. Okay, so the reason for that is when you're doing an eval with a synthetic data set, that means like you have a question answer which is like predominantly generated from the knowledge base that is supplied for the framework. So example, for all these synthetic data sets, you have a framework or a platform. Okay, and then you pass the knowledge and it is based on your ask, like let's say like 100 questions or 50 questions. So it will start generating that data set, right? Like question answer pairs or question answer context 3. So it's a tuple or trie. So anything. So you get this, and then we do that on a RAG. We apply that on a RAG, and then we say, okay, this is actually performing good. But what they claim is generation is always dynamic in nature. Okay, even though you evaluate on a certain parameters on your synthetic data set, at 101 question, this will deviate. Okay, but this is always good if you apply this synthetic data set on a retrieval phase, which will give you some idea on how your context is varying, and it will give you an opportunity to make tuning on your context parameters such that you are always aligned to that and you get the best context out of it. So synthetic data sets best give you the visibility of context in a retrieval phase. You align with that and then start applying your human eval or human generated data sets on generation phase. That's how they concluded the paper. Maybe I'll send it to Bala and he can circulate it, but that I felt very good. And then I thought of telling you, and then this is the best place to tell that. And coming to the next one, we have agents, right? So as I said, agents are of two things. Like one is non-conversational agents and the other one is conversational agents. I'll tell you two best examples here. Like conversational agents are like, as Bala was mentioning, right? So suddenly there is, okay, maybe I'll tell you, there is an IVR bot, and you called a medical agency, and then you said like, I have to book my doctor's appointment, or I just wanted to inquire about my insurance claim or something like that. So it will take some parameters from you. There is a conversation happening, and finally you get your answer back. But whereas the other analogy of it is non-conversational. Non-conversational is like 90% of the LinkedIn content is around non-conversational only these days. Okay, so you have a workflow, and then you want to automate that workflow, but not with the standard instructions and coding. Let the workflow decide its own actions based on the question that is being given, or a query that's being given by a user, and then every node of that workflow is an agent. So it will take its own action, pass the context to the next node, and then goes forward, and then finally you have a answer, and then you get it back. Or if there is an exception, it hooks and then asks for a human intervention, which is called HIL, human in the loop. Okay, that's how the workflows are designed. So now in these two sections, you have something here. Like if you see the last layer, right? So you have initialization performances. Like if you initialize an agent, how initialization performance of that agent is working, like how much of RAM, how much of memory, all these things you can measure and then see like, okay, if I my complex workflow is of like 50 different agents working together, like multi-agent systems example. So, and there is a word also coming into picture, which is called MAS, MAS, okay, multi-agent systems. Okay, so if that is the case, like if I deploy the entire multi-agent system into a production system and then scale it horizontally, like what could be my performance hit? So that is where like your initialization performance metrics of an agent or an evaluation of that agent is very important. Second thing is, every agent, I think, like I don't call something as an agent without a tool integrity. Okay, it's very bad to call just an LLM call as an agent. Okay, so an LLM hooked by a tool is like an agent, at least a basic definition, right? Because now LLM thinks and it knows some tool to call, and then it do some work for us and then give us at least a basic agent, right? So out of 10 different experiments, how much time reliably you called a given tool? Okay, that is one of the, again, evaluation parameter that we can do. And one insight here I just wanted to give you is, of course LLMs can handle multi-tool calls, but at least in my experience, if you hook an agent with a single tool, your reliabilities are like too high. Okay, so an agent with single tool, so maybe you can design n number of agents with n number of tools, but every agent is having a one-on-one relation with the tool call. I think like the best tool parameter reliability that I've seen is, if an agent has got 5, beyond 5 it starts hallucinating, it confuses most of the time, like what tool to call. Okay, that is one. And now if you go to the conversational events, so you have something called turn relevancy and turn faithfulness. Okay, so how efficiently the turn is been happening, that is the reliability part of it. And then the after the turn, like what is the faithfulness of the answer that we are getting it. Okay, so these are the two things that you can measure in a conversational agent perspective. So the entire thing, right, like the last two use cases, the RAG use case and the agents use case, both conversational, non-conversational, we'll be seeing it practically here. So now I just wanted to open a couple of minutes for questions if you have it in a very initial stage, else I'll start the demoing. Because before I just wanted to show the demo, I just wanted to see if there are any questions, other like we clear everything conceptually.
So Pawan, Samir here.
Hey Samir, yes please.
Hi. So initialization of performance and tool reliability, are these things not relevant for conversational agents? Like, do we not really?
No, we can, yes, because in conversational agents also, it's not simply like conversating, right? Of course,
Right.
like you ask something, it'll go to your database, fetch something and all. That's what exactly we were even discussing, like you can hook it to some kind of insurance or something like that, right? Yes, they are, but I just for now, for the demonstration, to make it more simpler, I just put it here. But tool is a common thing for both. I think I just kept it also, I guess. See this conversational agents, I just kept it in this side also.
Oh, yeah.
You are right. So now if you see, I just highlighted.
Yes. Yeah. Thank you.
Okay.
Digvijay, you want to ask?
Yeah. Hey, hi, Pawan. So regarding the synthetic dataset generation for that University of Amsterdam, the conclusion that you spoke about, when you mentioned that it said that for retrieval it's much better than generation. So did you see, like, the paper also mentioned about like, because you said that you haven't seen more than 75 to 80% accuracy in production systems. So with synthetic data set, were they able to achieve that as well, or they were just able to?
They were not talking about the accuracy aspects of it, but their argument was you should actually apply the synthetic data sets over, over the RAG pipelines to measure how your context is varying. So your synthetic data sets will help you to tune that context relevancy extraction. Okay. And then you should always include your human eval at the generation part of it, because generation is more dynamic in nature, such that like human understand it whether the given answer is right or wrong. There is no synthetic data that can measure directly and coherently whether the generated answer is very much relevant to a user's question. Because like if example, like it's very much practical also, right? Like if we have example, let's say 100, or like it's very low, but I'll put it for rounding. So 100 questions of something like Q&A page along with, I think like you are already seeing my screen, right? So if this is the kind of a data set, right? Like you have a question, context, and an answer. Okay, assume that this is very small, but assume that you have a very long chain, like 100 or something like that. So assume we measured in two directions. One, according to this synthetic data set, like we measured how context is working, and at the same time, from a generation perspective, how our generated answer is aligned to the ground truth answer. But there is always a possibility that a user can ask, I think how many are there? Maybe like 100 line. Maybe I can say like 200 question might be asked. And that I cannot even measure with the ground truth dataset. So ground truth dataset will clearly give us, okay, if these are the kind of questions, this is how my context is being coming. Maybe you can do your vector stores, HNSW, EF parameter fine tuning, sharding, multi-tenancy approaches. So all these things you can tune such that you can generalize, okay, if this is the question, this is how my context is going to come. Even after 100, 120 or 130, at least I can sustain to an extent that my context doesn't deviate. That is what their argument was. It's not on the relevancy approaches, of course, maybe like there are many other papers, but this paper is predominantly telling you should use your synthetic data sets to fine tune or tune your context extraction, such that like it will be very helpful for an LLM to understand what exactly, and it will generate a good answer, and then involve your human to validate that.
Got it. Thank you.
Yeah. Perfect. I think like very good questions.
There is one question on chat from Shubham.
Oh, really? Just a second.
What is the best way to
What is the best way to evaluate the multi-turn communication? Okay. So I just wanted to differ this best way. Okay. The reason for that is there is no best way even till date. Okay. There are some standards. Okay. You have to experiment with these standards in permutation and combination way, even though they say like there are 10 different things. Now what we have to do is we have to do a permutation and combination of these 10 different things, and then see like what is actually coming out best for our use case. Because in this what I can say is gen of AI or generative AI, use cases are like highly different for everyone, each of us, right? Like I may be working on something, you may be working on something. What the methodology that I say will never fit into your use case, but as is, when you apply as is, that's what I meant. So but if you take the conceptual approach, tune it a little bit, and then apply to your use case, maybe that will work. So that's how all these systems are, at least in this current situation. Okay, so as such, there is no best way, but there are few ways. Like as I said, like two approaches are like you can measure the faithfulness, conversational relevancy, the turn accuracies. So all these things you can measure and say that, okay, fine, like out of my 20 conversational experiments, I always feel that like conversational and then recognition, like word recognition is very much appropriate. Like it is actually recognizing whatever I'm saying. So that is your best use case, right? Like that thing that you can say, and then okay, maybe you can upgrade your systems to pre-beta and then give it to your elite customers and pilot customers and say, okay, now start using it. So that's how it is. Okay. And okay, let's see something which is very interesting for you guys. Okay, I always call this as VLAG. I don't know if you've seen my post or not. As Bala says, I created a framework called, I didn't create it. Basically, like I named some of the tools, I made it, created as a pipeline and experiment many things, and then found this is reliably working, at least to me. That's called VLAQ. Okay, VLAQ. I'm putting it in chat. Okay, that's one of the stack I can call, which is very much equivalent to your MERN stack. And if you are a full stack developer, we would have predominantly worked on MERNs and PERNs, right? So very similar to that. In Gen AI, this is working good for me. So V stands for VLLMs, where you can host your own infrastructure LLMs, such that like privacy first. Okay, so your data doesn't go out of your four walls. And then L for Llama Index, the best data context retrieving and data generation framework. And then A for Agno for the agentic framework. C for Chunky. To do this RAG, you need to have this chunking, chunk overlapping and all those things. So Chunky is the good library that I found. And then Q is the quadrant, which is the vector search engine, where you can push this data into the quadrant and then get it back out of it, right? So these are the tools that very similar to, as I said, like MERN, like you have all these are like different frameworks and tools, right? When you combine, that becomes a MERN stack, and very similar to this, all these stacks combined, it becomes a VLAQ for me. So I'll experiment and I'll show you a little demonstration with VLAQ, and then we'll see a couple of evals on top of this pipeline. Okay. So let me show my data set first of all. So I have something called leukemia PDF. So if you are very much interested in medicine and medical terminologies, I think like you can join me. But if you are not interested, just bear with me for next 1.5 hours or 1 hour, where you'll see a lot of medical terms that I talked. Okay. So leukemia, I think like we all know, it's like cancer. Okay, so we have different sectors of cancers, right? Like AML, ALL, and all those things. Of course, these are like short forms of it, right? So I've got this. Maybe like I'll show you that doc as well. Just a second. Okay, this is taken from the University of Medical Research, I think Cambridge, if I'm not wrong. So I was doing some study on this. So this is like different parts of it, like how leukemia, what is different types of leukemias and everything such kind of explanation was given. And now what we'll do is we'll use this VLAQ stack. Okay. And then I'll show you the components of VLAQ stack, and then finally ingest this document into our search engine. Okay, and then start doing our evals simultaneously with the agent that we run. Okay, so we have a RAG agent created. I think you can see that as well. So we have a RAG agent here. Okay, you start questioning it. Simultaneously, what it does is it does an evals and give you like what aspects are actually doing well and how much score that it belongs to. And this is how, when you are creating a bot, maybe in your production environment, you should actually adhere to these kind of mechanisms, where you give the response back to the user. In the background, you may have to record this for your further analysis. Okay, at some point in time, if someone says that somehow from the last 1 week, I'm seeing a degradation inside the model, highly possible. Reason being is there are two things, right? Model drift and data drift. You cannot eliminate these two things. So if that is from a last 1 week, someone gives you that feedback, you should always have the circumstantial evidence that you go back into your timeline and then see like, okay, from the last 1 week, like what is my scores, average scoring? Okay, for both things, from the retrieval perspective and from the generation perspective. That is where you will come to know a lot of insights. Okay, there is something happening really, and that's where like customers are also poaching us, saying that okay, there is something bad happening, and there is always a scope that you can actually go and then maybe let's say refine it and come back, since you have the data. And then on top of this data, you can create your data set, and then now you can start again tuning your retrieval aspect of this, which will act eventually as your golden data set. Okay, so one note out of my experience, like where it pinched me a lot in my initial stages. Okay, so so we have 3 stages here. one, you saw the PDF. So what I'll do is PDF to image. Okay, this is another interesting part of it. How many of you work there with PDFs? Okay, PDFs. Okay, so we send a PDF, or we do some kind of like, what do you say, like PyMU PDF, like where, or a PDF plumber. We'll extract all the PDF or go through the PDF, get the text out of it, chunk it, and then maybe try to do all of these things, right? There is an interesting finding that I've done, but still it's in experimentation stage. Once done, I'll make it public. Thing is, like, if you post a PDF, direct PDF or a text of the PDF, your tokens are too huge. Okay. And if your PDFs are, like, I saw, like last week I was talking to another community, my own MTech community. Someone actually gave me an invoice which is almost a 238-page invoice. I first time saw that huge invoice. Yeah. So so now if you do processing on those kind of things, right, or if you just take a textbook of medical or some lawsuits, so they'll be too huge, and your tokens just like that, they'll vanish. Okay, even though you have 1 million contacts, 2 million contacts. 2 million context is basically, people most of the time they understand it wrong. It's like question and answer combined is called a context. Okay, so it will easily vanish. Okay, and then if you have the history in place, and if you want to inject this context for every question, I don't know how much we'll save also. Okay, so the identification that I've done is, you do a textual injection and then see the token count. You take an image of that and then do a contextual injection and then see the token count. This highly varies. 60% of the tokens fall down the critical limits, but both are same. I'm just sending a text here, but I'm sending an image instead of a text here. Okay, so that's interesting identification that I've done, but I'm still not pretty sure. I'm just giving you as a word, and then you can also start your experimentation and then endorse if this actually works. Okay, so what we'll do is here now the same thing. We'll do a PDF to image. Okay, so every page is converted as images and send it to an LLM. LLM will give us back the exact text what it sees. So there is, and one more thing is, it will not deviate. Okay, because when you give a text, so it has to go through, it may hallucinate because some context may be on top down or something like that. So here it is visually see, so there is no deviation. Okay, and then what we do is, once we get the text, we convert that as a markdown. Okay, so here we have something called PDF to image and image to markdown. Okay, so PDF first, images are converted, images are again converted to markdown, markdowns are again chunked and then finally ingested to our vector search. So that's the pipeline. And then on top of that, we will put a lot of things, like we put agents to retrieve, query, and all those things. That's a fun activity, but now we'll see this. Okay, so I have something called execute RAG pipeline. See this is just a workflow, very simple workflow. So you have PDF image, that class main file I'm calling, and then image to markdown, again the respective main, and then ingest data to store with fetch is one of the method in chunky, and then I'm just putting that. Let's go and see these three methods now. First of all, like very top level, very high level, we'll see that. So PDF to image, very simple function where I'm going to my datasets, extract that, convert every page into an image, store it in one location. Okay, so they will put it in this finally they will save this here with the page number as an image name. And now go to the image markdown. Now it's very easy to guess, right, from the previous step. That means we know already where the images are stored. From there, like, I'll extract, send it to LLM, and then the interesting part of this code is the LLM aspect of it. Like what I'm using, I'm not using Gemini, I'm not using your whatever OpenAIs or Anthropics. Okay, I'm using Docklink with IBM Granite, and both are hosted in my local with my Olama. Okay, so see this. Okay, Granite 3.2 Vision latest, which is in Olama, which is just like 2.4 gigs, but best works. Okay, caution is it should be on Mac. Windows, I don't know. Of course, you will have a lot of trouble with Windows. Okay, so so now if you see this, I gave the path as PDF as images, like where the images are stored, and then it start processing. And now I told that like vision language model specification pointing towards my Granite VLM Olama. Okay, and this converts into markdowns, and finally you have a markdown. And then okay, ingest to vector store. If you see this, I have two different methods. These two different methods are methodologies, like altogether different methodologies. One uses a file fetch directly, it will read from a file. The other one is you need to send a text towards the method, and that particular text is ingested. So you have a controlled approach on the method too, where you want to control what to be ingested, what not to be ingested. And second one is like you don't have a control, you just tell what file it is, it will do whatever it wants. And at the same time, another approach that is differing here is in the file approach, I experimented with something called a recursive chunking technique, and the other one is with the semantic chunking technique. Okay, so as I say, right, in RAG, I do a lot of experimentation, and this is one such example, like two different methods, two different experiments, two different permutation combinations. Okay, now with this, let's go back to execute RAG, and this is the PDF as images folder. Just check it, like I'm in front of you, I'm just refreshing so that like we get confidence that nothing is there. Okay, now I'm running this. Hope nothing works. We all software engineers, and we know that demos fail. Okay, so in front of the customer you go, like whole night we will work, everything is working. In front of the customer you sit and then start demoing, it fails. Okay, so docklink started. Now if you see this, okay, it started, it is actually creating, immediately deleting also. But for our thing evidence, we will see this 6, 7, 8 are still there. So it's actually working in async mode. So now, so that's the reason, like as soon as it is created, it is consumed, and then it is deleting them. And what happened is after this, it created the MD also, if I'm not wrong. Yeah. Okay. So here is the markdown format. And then what are these batches? So your quadrant came into picture, the chunky came into picture, it started chunking according to the file ingestion, because MD is a file for us. So we triggered that method, and then it started chunking into batches and then finally ingested. Let us see the quadrant now. Okay. So let's go to collections. Okay, we don't have it here. Okay, refresh. We don't have it here. Okay, let's go to page 2. Now see this leukemia knowledge, which has got 74 points ingested. Okay, so okay, this is good. So we have all the data ready now. So what we'll do is we'll invoke our agent, right? So let me close all tabs. It's very confusing. Okay, so let me take the agent. It's very simple agent, guys. Okay, so I have all the LLM calls, like I use Gemini, I use Claude, I experimented with Claude, I experimented with OpenAI chat, I experimented with Olama, and even VLLM also. But I think like time won't be sufficient, so I deleted that VLLM aspect for this session. So I have two things to show before we go into the agent and evals. So I have a tool here. Okay, this tool is basically to hit the, or to connect with the quadrant search engine and then get the data out of it according to the query that is passed to it. So there is a query and we pass it, and max result, max top K is 10 of the context retrieval, right? And I'm not going deep into it. Of course, this is all written on top of Llama index. Okay, and now go to something called prompts. So there is a very clear instruction of a system prompt saying that it's a leukemia doctor and a medical oncologist, and then it knows all the different leukemia categories like ALL, AML, CLL, AL, and all those things. And there is an important note at the end where it says like you should never answer anything outside of leukemia. And if it gets anything outside of leukemia, I'm sorry. Okay, just say, even though it has got the context, it should just simply ignore it. Okay, so that's how, like, we just, it's very, very precise, concise, and sharp prompt. That's it. Okay, and let's go to the agent. Okay, and now if you see this is actually created in Agno. So agent is a class in Agno. Agno is a pretty good framework here, and of course I'll tell you one thing why you should actually start looking into Agno. By any chance you all know ThoughtWorks? Yeah. So ThoughtWorks is a very good company from both, like I think like they do have products, but they do a lot of research and surveying research, basically public survey research, right? So I think like a month back they published a very good deep research, public research, I think flyer or a PDF doc. I don't know what should say, survey results. Okay, in which they emphasize two agentic frameworks. Okay, one, LangGraph, worth to implement. Second, they wrote like something like that, worth to implement, and then Agno, worth to look at. Okay, only two, nothing else. You have 7-8 different agentic frameworks. IBM B is one, OpenAI agents is one, and then you have Crew AI. Like too many people do like too many experiments with Crew AI. Nothing. Like these are the only two frameworks. They're LangGraph and then this one. Somehow LangGraph I do it, but I don't get some confidence, so I shift back to Lang. Okay, so so this is very simple framework, guys. Okay, so agent, and then you give a lot of parameters to it, like how your agent should be constructed with model, tools. Tool is what? Like our own tool, like what we designed for retrieving our context. And now the debug mode is true. The reason being is we can see the trace of how the agent is executing. And then you have a system message, the system prompt that we have designed. And there is an additional instruction, like whatever you give now, finally give it in either bullet or tabular format, so that like it is easy for us to understand. Okay. And finally, I'm returning this agent and then say, and now I have a query here. This is very specific to leukemia. How does the blast percentage differ between acute and chronic leukemia? Okay, there is something called blast in our WBC. Happens when a candidate is attacked with a leukemia. There is something called a blast happening. So that we need, that is a question that I'm asking. Okay, and now what happens is agent will run that query. I get a response, and I'll collect that. When I say response.content, I'll get the exact response from the agent. So I'm collecting that as an agent response. And now I'm collecting the context also. What is the context that is injected or fed to this agent? So I'm checking if this response.tools has got some tool invoked. If there is a tool invoked, I'm just getting the tool.result. What is the result of that particular tool? Okay. If there are n number of tools, it will put everything and create a contextual array for us. Okay. Very simple for loop and if logic. Now what I'm doing is I created a different evals file itself or a script where I'm measuring context relevancy, answer relevancy, and faithfulness. So for every question that you ask, okay, simultaneously it will answer the agent and it will measure the relevancies and it will give you. So this is what exactly I was saying. These later three are for us. Like we will put it into our database. Of course, it is not there here. And of course, it is not even relevant to the session. So we'll store it, but the response is propagated back to the user. Okay. So now what happens is you have two things. No, now people are seeing the relevances. At the same time, you can also have a monitoring dashboard, like how your evals are going up and down. There is a fluctuation, or you are making a watermark the thresholds or something like that. You can have a clear visibility. If something is coming down, you can actually put some kind of alerting on top of that, saying that by like from last 1.5 day or 24 hours, your evals are always on an average, they are below your threshold. So these are the kinds of things that we have to put in place for your RAG pipelines inside your production environment. So let's run and see. Okay, so now I can say RAG agent, if I'm not wrong, this runs hopefully. Okay. How many ever times we do an experiment at the starting of running a demo, no, I'll feel that fear. So see this is beauty, no? So okay, see this agent ID. There is a unique agent ID that's get created. These are all actually you should store all these things into some kind of sessions. what agent has run, at what session it has run. So this will be very, very useful for contextual ingestion. Okay, so if you are creating a memory, okay, for an agent, these are all very important. Okay, so now you see this system is the system prompt, and there is a tool call here happened, and the tool name is this one, and the query passed to tool is this. You can see the metrics for this, tokens consumed by this point in time, and there is context retrieved is this is good. And finally, let's see the answer now. It called twice, and okay, I think like this is the, I don't know if I didn't print the answer if I'm not wrong, but okay, it's my bad. Okay, I think we do have 2 metrics already. Context relevancy is like 0.87%, 87%, which is very good. Answer relevancy is 85%, and you have the reasons for that. And I think the response is here. Okay, sorry. Yeah, the response is here. Okay, so this is the response of the agent. Okay, and the last one we'll also see. Answer faithfulness is like 66%. This has come down below 70%. I don't know why, I have to look into it. But otherwise, this is the best thing. No, you ask the question and then it is able to clearly tell you like what is the score of it and what is the metrics that is being executed. And finally, you see this. I even did hooked a small experiment at the end, which is called a reliability summary. Okay, so it actually executed the tool thrice. Maybe it's going into a loop thrice and then it was doing it, or it executed my reliability metrics as that like I clearly told you have to run 3 times, and every time when you run the agent, the tool should be called. There is no excuse. So it called 3 times, and every time the evaluation success is passed. So this is called the reliability metric, checking how reliably the agent is working. Okay, so and then finally reliability result is passed, and then yeah, this is something that you can do with this as a log or something. But now you are understanding, right? This is how an agent, this is non-conversational agent. Okay, a non-conversational agent, and moreover, like we combined actually 2 different concepts. I don't know if you still noticed it or not. We have done something called agentic RAG. Okay, an agent which is actually hooking to your RAG system and getting it. So this is an agentic RAG. Of course, agentic RAG could be even more depth, but this is very high level, very I can say is very novice or a very layman way of building it, where you have only one agent which is actually thinking and doing all the tasks for you. Okay, so let me show you something else also now. RAG agent evals. Okay.
Yeah, we want to see how the evals is built. Like how do you build the evals for?
Exactly. That's what I was coming to. Okay. So RAG agent eval. Oh, okay. Where is that? RAG evals. Yeah, this is the one. Okay. So these are the things. So now it's time for us to know like how the evals, or like what I use to build these evals. There are 2 players in the market. One, your Ragas. Okay, I forgot the corporation of them, but it's Ragas, and the other one is DeepEval. Okay, these are the 2 frameworks which will give you the standard methodology of measuring your any GenAI application, applied GenAI apps. Okay, it could be agents, it could be RAG, it could be conversational agent, anything. They have some set of predefined frameworks which you can easily hook into your apps and then start measuring them. So now if you see them again, most of my work would be on local, such that you all feel more comfortable, right? Like playing in local instead of paying something externally. Only one call I made, external call. I don't know if you still realize that. Okay, this is the Claude Sonnet. Okay, only my RAG agent, after getting the context, it sent it to the Claude and then got the response. I might have done even with Olama also. Here I even configured. Okay, but just for a flavor, I just removed it. Okay, so now if you go to the RAG, every metric is actually using my Granite 4 3B. Now you can eventually call the entire thing that we are doing in this session is an IBM pipeline. I was using Granite 4 Vision, and I was doing that Granite 3.2 vision and Granite 4 3 billion models. So IBM models are pretty good here. I don't know, they are not coming into limelight, but they are doing a phenomenal job actually. Okay, so I see this context relevancy, answer relevancy, faithfulness, everything is on the Ollama model hitting my Granite. Okay, and now there is a structure that needs to be built for getting the evals into play or into an action. So DeepEval suggests something that evals are nothing but your test cases. Okay, so they given a class something called LLM test case, and for which you need to pass your input, actual output, and relevant context. Okay, and there is one more parameter also which is called expected output, which is nothing but your ground truth. For our use cases, I don't need the ground truth, so I just remove them. So what we are measuring is context relevancy dot measure this test case and then return this response. Okay, and then similarly you have answer relevancy, test this test case and then return the response. Similarly, you have faithfulness, test the test case and then send. So now you can do it in a ground truth that I have been showing in the start of the session, right? You can write a for loop, ingest all these questions, and then check how your scores are measuring. Based on that, you can tune your context, or you can hook these evaluations into a live agent, what we have done now, and get how those are getting picture. So this is one. Now we'll also see, of course, I have built very layman evals of Ragas. This is all E2E, end-to-end eval pipeline, complete pipeline of ingestion till evaluation. Now we'll see context relevancy. So you have a lot of things, context entity recall, okay, and then you have context evals, context precision, how well the context is aligning, that's called context precision. Okay, and then context precision and utility, of course this is MD. So for everything I've written an MD file where you have a math also, like how it is being computed. Okay, and maybe like I'll commit this into the GitHub and then you can just fork it out, go through it and then check it and let me know if you have any questions. But otherwise context recall is another one, and then context utilization. Okay, this is also one more important feature that we can use. And one very good thing is you can use both Ragas and DeepEval simultaneously in a single project, or DeepEval will give you a tight integrations towards Ragas also. Like whatever the eval metric that DeepEval is not providing, they have an integration directly to Ragas. So you can pull those Ragas evals. If you just wanted to use only one eval framework, not both, that also you can do. So context utilization is, let's say you have given some lengthier context and you have got some answer. So what percentage of the context was actually utilized for giving or for generating this particular answer? So that is the best one. Out of which what we will gain is how much of unwanted context is going, how many tokens are being consumed, and how I can optimize my context. Context optimization is another big problem in RAGs. So that we will come to know with the context utilization metric, how much of the context is being utilized. Okay, so let's see. I'll run this context utilization for you and then I'll show you. Of course, here I'm using GPT-4o mini directly the OpenAI one. But otherwise in Ragas, you don't have a direct integration towards Ollama, but they do have something called custom LLM creation, where you should create that class and then hook it to your Ollama. Now see, this context utilization is only 49.99. So only 50% of the context is being utilized. Otherwise, like it's not exactly, no. So you have two statements here, which out of which only one is relevant, other one is irrelevant, literally. Okay, so that's how you can measure how much of the context is wanted versus unwanted, and using these percentage scores, you will get a lot of insight. Okay, how to truncate, how to. I think I saw something in LinkedIn today morning only again. There is something called context tuning. Okay, so that is, I think, this one itself. I didn't read that, but it is actually relating to that. How do you tune your context so that it is very precise, concise, and focused and crisp? And then you ingest your LLM, and it is giving you some grounded answer without hallucinations. Okay, and we have very much similar to that. We have a generation. The generation are very similar, like the same thing, like your answer, relevancy, faithfulness. And now whatever you see, the independent ones, right? Not the E2E evals, not the E2E eval pipeline, but the context evals and the generation eval. These are designed on the Ragas. See this. Okay. Our E2E pipeline evals are built on DeepEval. Okay. And these independent concepts to experiment and know what exactly is happening is built on Ragas. Okay. Reason for this to do is we will get the touch and flavor of both the frameworks, and we will come to know how both will work, and we will have the knowledge of both of these frameworks, like what to use, what not to use, when to choose what framework. Okay, so this is my intention to build the entire thing on 2 different frameworks for us, which are available in the market. And good thing is both are open source.
Pawan, can you take us through let's say a prompt for one of these events? Like how do you structure like a prompt for a specific use case?
Oh, prompt for a specific use case, right? You mean say
evals actually. So let's
only
say
evals.
Yeah, for
Yeah,
Facebook,
okay.
if you want to do, how would I build a prompt, or how do I, give the instruction to the LLM on how to calculate faithfulness? So something like that would be useful.
That's a tricky one. Actually, I don't have something ready-made or handy available.
Okay.
But
So is it something that comes with part of the framework? Like
yes,
you don't
yes. That's what I was about to show you actually. Answer relevancy. Okay.
I thought we have to instruct the LLM on how to calculate relevancy.
No, they are part of this framework actually.
Interesting.
Answer relevancy prompt. If you see this is the one. Okay, you can actually modify this according to the use case, but otherwise by default they do have this instruction. See, generate a question for the given answer, identify, vague, and then you have 0 if the answer is substantiative, and then non-committal answers, I don't know, something like this. And then they do have, see this.
Got it.
So they have all these things like they, and if you go to their websites also, they will say you have a customization also. Of course, we ourselves can see this. So they have something called step.prompt and giving this, like we can override this prompt with this our own prompt, and then it will start working according to our own prompt.
Fair enough.
Okay, so with this, I think it's time for us to see a conversational agent. But before I bring up that conversational agent, like if you have any questions, let's have 1 or 2 minutes conversation on the clarification of the doubts, and then I'll bring up my conversational agent.
Yeah, I had one question around. There is this system level instruction you gave, right? Like only respond from the context that you actually have. Don't use the general knowledge, right? So what kind of evaluation would I use for something like that? Basically, I want to reduce hallucinations is the goal here. So how do I set up an evaluation for something like that?
That's the reason I said like context utilization. So if the context utilization, yeah, I was expecting this question. So if your context utilization falls beyond some threshold, let's say you always say my context utilization should be above 80. So that means like whatever you are giving it, LLM is actually consuming that. Okay, if your context evaluation falls below 80, that means there is some hallucination or some irrelevant context going in. When you say irrelevant context is going in, then there is always a probability that hallucination can happen.
Interesting. Fair enough. That's a good idea. There are a few questions on the chat.
There are a lot actually. So I don't know. I think like I'm seeing. Okay, is correct, true or false? Score 0 to 10. Read what is this? Okay, system round. Are you unexpected? Okay, fine. Similar to what Bala asked, I have the above one. Perfect. Yes. I don't know who this is. Gurunath. Okay. I think this is beauty. Yes. You can do. Similar to this, you have seen in their standard framework also, right? Like they told like you score it as 0, 1 and all those things. Of course, all these prompting of evals will come under an umbrella called LLM as judge. That's a bigger concept actually. So we drive the LLMs as the judge for another LLM which gave us an answer. It's always a good practice that if you are one LLM, now if you see my LLM was Claude who gave me an answer, but my evals that is being evaluating that answer is Granite 4 in Olama. These are two different LLMs altogether whose architectures are different. Of course, transformers underline, but their heads and everything, the number of layers, everything they differ. So the inference differs, the training data sets differs, everything differs. So this is always a good practice that you have your LLM as judge as a different family, and your actual LLM who is actually responsible for your agent driving should be different. At least I believe. Okay, this is the best practice. Otherwise, there is another concept of evals. It's called mixture of experts LLM evals. That means you can have 3-4 LLM agents which can evaluate a single answer and ensemble that and give you back. So that's a little trickier concept, but maybe some point in time later, like if we have got one more interaction session, something like that, I'll even explain you that. So it's like that, like me, Bala and someone as a jury, we'll evaluate one candidate in interviews, example, right? So, and then finally what we do, we collate all the results and then take an average, weighted average, and take a decision on top of that, whether the candidate should be selected or not, right? Similarly, you can put 3 evaluation agents evaluating a single answer, and finally you define a criteria of some averageness or something like that, and take a decision how to deal with that particular answer, whether from a perspective of context or from a perspective of generation. Either of this. This is called mixture of agent evals. It's my concept. Nowhere it is there. It's my concept. Like I've done it. I've seen good results, and then I just published on to my org also. Like they were doing it. They are doing it better. Okay. So thumbs up to Gurunath. Yes, that is actually relevant. And is there a thumb rule on selecting which metric to use during eval? No thumb rule, but as I said, like it depends on the use case. Either you are dealing with agent versus RAG versus conversation. It depends on all these things. And then based on that, you take a decision what to use, what not to use. Okay, the value of context utilization is defined by the LLM framework itself. As a developer or a PM, we define the value, and if we do that, how should we commit appropriate value? I didn't understand. Samir, can you unmute and then tell me?
Yeah, sure. So the context utilization value that you just showed in one of the examples, it was 49 or something, right?
Yes.
So whether that 49 is too low or too high, or is that something that is defined by the LLM framework itself, or as a developer or a PM, I am supposed to identify what is the value of the context utilization should be for each case?
Both can be done, right?
Okay.
Example, simple math. Okay, if you just step from a framework perspective, software perspective, come back into the math, we do this blue scores and all, right? Like bird scoring, blue scoring, how much of rogue scoring, how much of the answer is matching with the existing thing that we have, or we can actually do something called cosine similarity, how much closely we are aligning to the context. These 3 things we can do it from a mathematical perspective, but 49% or 39%, whether that is actually aligned to that or not, it is dependent on the use cases. Example, let's say if I am actually in the medical field, nothing below 95 is accepted. Okay.
Yeah.
So that thresholds I can set, because we do have the due diligence and that knowledge base from our ages that we are working, right? So you have that intuition. Okay, for this particular use case, I can never drop below some certain levels. You put that level, give the freedom to an LLM, or maybe customize the prompt in such a way that, like, you have the provision to customize. I've shown that as well, right?
Yeah.
So you customize the prompt and strictly pass the instructions like if you are getting these kind of things, then you validate or score in this manner. That also is possible. Or as I said, like create tools, fall back to the math approaches on relevancy, blue scoreboard score, and then do it. Or else even the point that I was telling you, you put 3 to 4 eval agents, ensemble all the results and take a decision on top of it. Because one can say 60%, one can say 73%, the other can say like 48%. Now, if you average all these things, you will have more deep the nuance or more deep focus, like what is happening on an average. If everyone is saying 80, then it is fine. If everyone is differing, then there is something wrong.
Yeah, got it. Thank you, Pawan. Thanks.
Yep. Okay. Think good questions. Okay, there is one more, I guess. Okay. Seems like context relevancy utilization drives a lot of impact on generation 2. So intuitively after this call, I feel that solving for context eval must be the higher priority than generative evals. Yes, absolutely. In RAG also, your retrieval is the core part of it than generation. Reason for that is if your retrieval is screwed up, your generation will all automatically get screwed up because it's a ripple effect. Very similar to that. Context relevancy, that's a whole point, right? Andre Kapati comes to the stage and then he says something goes viral, and then the latest one that he told is context engineering. Why did he see that? Because of this only. If you are putting something which is like not relevant to an LLM, obviously you expect unrelevant things only coming out of an LLM. So that is where like context engineering is highly important, or context relevance is highly important. Whatever your understanding is right. Okay, and then okay. Now I'll pause the questions and we'll take it at the end. Without wasting more time, I'll show you something which I've designed. Maybe I'm designing it for my next blog, but I'll show you. Okay, so I've designed something on by using a framework called PipeCat. Okay, PipeCat and LiveKit. These are the two conversational frameworks available in the market for open source, where you can build your own conversational agents. Okay. Just before this, me and Bala was talking like what is best. Okay, so LiveKit, you know, how many of you guys used what is this OpenAI live chatting, like the voice agents of OpenAI? So you just press it and ask it, it will do that, right? The entire infrastructure is designed by LiveKit. I don't know if you all know that or not. Okay, so that means it is proven by such a huge volume of requests. So LiveKit is able to prove that it works. Okay, so both are best, nothing contradicting anything, but learning curve when perspective to the LiveKit is a little more when compared to PipeCat. PipeCat is very simple, easy to learn, so very good features. Feature wise, you cannot tell this is best versus not best, but both are good. But learning curve, when you want to go deep and learn things, LiveKit has got more things to learn, but whereas PipeCat has got very simplified version, abstracted version. So it will be easy for you guys to kick it. So now this is the conversational agent. I'm not going through the entire code base. I think like we are hitting time now. So what I'll do is now I'll explain the critical parts or critical aspects of the code. Okay, so there is a pipeline here. Okay, in PipeCat or LiveKit, both they worked on a pipeline. Okay, so you have something called transcript input, which is like from a user, and then you have RTVI processing. Okay, and then you have STT, speech to text, because I'm converting in speech, so it has to be translated to text. So speech to text, and then the user response, and then goes to LLM, and then to TTS, text to speech now, because it understood text to speech, and then a transport layer, because I'm putting back and forth towards a web UI. And then finally, we have a context aggregator, because when you are conversating next, so my previous context has to be engineered and given back to the agent or LLM. So I'm doing this. So this is the simple pipeline that you can. This is called chained pipeline or aggregated pipelines, or some names are there in industry. But this you can just follow that. Your speech then goes to STT, then goes to LLM, and then goes to TTS. Okay, so this is the pipeline. And one small thing that I added is actually this logic. here is not there previously. When you go into the standard documentation also, it's not there. This is the logic that I've added, these slides. Okay, so according to the standard documentation, it is just this: on client connected. So you have the logger client connected, and then it will start kicking in the LLMs. But I want to capture what is happening in between. So what I did is I just captured every message and checking if there is a user turn or an assistant turn, and I'm creating a conversational turns test case. Okay, so I've designed a test case here. Okay, conversational turns is just an array which will have array of turn objects. Okay, so that turn objects are appending each at this time with role like user and then content in the system and the content. And if there is an even pairs happening, very brute force approach, that means like user and system conversation both are present, then I'm triggering the conversational test case from DeepEval. Okay, so that's the whole motto of this. Let me start this. Maybe I have to reshare that I have to do because I was doing this experiment just before even the presentation started. So, okay, so let me click this. I'll stop and share so that you can also hear the conversation. Okay. Okay, I'm connecting my thing.
Hello, I'm your friendly AI assistant here to help with any questions or tasks you might have. Whether you're looking for information, advice, or just a chat, I'm here to make things easier for you. How can I assist you today?
Hi, I started with creating the conversational agent evaluation framework. I think I'm in a process of evaluating them.
That sounds like a really interesting and important project. Evaluating conversational agents can help ensure they meet user needs and function effectively. What aspects are you focusing on in your evaluation framework? Are you looking into factors like user satisfaction, accuracy, response time, or something else?
Hope you guys heard what agent and myself we were talking. And then now if you see this, in between the conversations. Okay, in between the conversations. So this should be your log. Someone was asking like in conversations also, can we do this? Yes, that's the proof.
The logs.
Sorry?
Are you showing?
Oh, okay. You're not seeing the log. Yeah. One second.
Yeah.
Sorry, it's my bad. So so if you're seeing these logs, right? See this in between the conversations, like my sorry, where is it? Yeah, my turn faithfulness and relevancy metrics triggered immediately when it hit that percentile 2 logic, which is which is funny logic, right? So and then metric summary, turn relevancy score 1, threshold of 0.5, and turn faithful score is also 1, reasoning, and then it has its own reasons, and then the turns like what assistant said, what user said, and then the turn relevancy accuracy is 100% pass rate, turn relevancy is 100, faithfulness is 100% pass rate, and of course there is a warning that there is no hyperparameters log. That is fine, but on the whole the token cost is saying and then the test results like one test case 100% pass, nothing failed. So now this is how, so as the conversation goes now, keeps going, I don't want to prolong it, but as it goes it keeps kicking and then telling you, and you can lively monitor if there are any deviation in the metrics or not. So these are the logs which gets accumulated or aggregated into my OLAP, analytic processing systems. Going forward, I can ask like for one particular day, what is my turn relevancy of my so-and-so agent? So it will tell like on the whole day, what is your average? or maybe for a particular agent ID. If this is the agent ID, what is my turn relevancy? So if you saw that my previous RAG agent where I was telling you agent ID. So for every agent return, there is a unique agent ID that's being generated. So if you have n number of agents in mass, multi-agent system, so this is how you can actually measure for every agent, what is the turn accuracies versus the faithfulness. So lot of things that you can actually measure out of this. So this is how, on the whole, evals will give you a lot of insights. Okay, so without evals, I think like Gen AI applications or applied Gen AI is just like 50%, not more than that. So if you hook evals with your applied Gen AI, that becomes at least like 70-80% of the end-to-end. Of course, infrastructure monitoring, scaling, everything caters to next 20%, which makes them 100% now. With that, I think I rest, and then you have any questions, you can just start asking, and then we can wind up the session. I know, I think like I've taken 1.5 hours.
No, this is fantastic. Folks, any questions? All right, I'll go first. I had one. Yeah, there is one from Shuchitra. Can you share this GitHub repo?
Obviously, I'll do that.
Yeah, we'll put all of these along with the the video.
But one thing is, whenever we are sharing the GitHub video, you should star it, thumbs up, everything as an open source guidelines. So you should always give it back, like saying that, okay, contribute, or maybe thumbs up, or 4K, contribute back into the repo, anything.
Yeah, for sure. Cool. So I had one question in the multi-turn conversation, right? So a lot of times the topic is covered over multiple multiple turns, right? So in the first 2 messages, I may not even have set up the context or anything else. How do I run evals during that situation? Because the scores will change quite a bit, right?
Yes. So 2 things here. Maybe like you should always have a threshold on the test cases injection. That means like only if you have 10 conversations length, then only your evals will get started. Otherwise, your eval engine will not even get started. Reason being is it is not worth to evaluate in the initial point of the conversation, because we know that without building a context, it is not worthy to start eval. Okay, that is one. Otherwise, there should be a threshold saying that, okay, I'll start the engine, no issue. But as we turn the conversational turn limit as 10, my eval's accuracy should go up. Something from maybe like 10%, 5% to maybe like 68% or 70%. That should be my growth rate with respect to the evals when our turn conversation length increases to 10 or something like that. So which proves that, okay, there is initially there is nothing, but as when the conversation starts building, there is more and more relevant context coming, and this proves that evals are actually getting improved, or maybe getting evaled in a right direction.
Makes sense.
We can actually do in both the directions.
Makes sense. I have one more question, which is around. So there are some custom evals that need to be done. For example, in some cases, I want to do PA masking. Right? In a lot of conversations, it actually doesn't happen. The second thing is, sometimes I also want to evaluate the emotional state of a customer. This is largely involved in customer support kind of use cases, right? So do I create like custom evals for this, or is there any recommendations that you actually have?
Custom evals are mandatory. As I said, like in the initial thing also, I said like when we started the presentation, I started custom evals are mandatory, but the standard evals metrics are something like which will give us a quick start, like and then we can build the things with some kind of confidence. Okay, building with ease is one thing, building with confidence is the other thing. Second thing is most important. And now building custom evals is actually needed. Reason being is not all the things are actually relevant to the use cases that we deal it in day-to-day activities. Like our customer use cases are 100% volatile. Like we don't know what he'll ask also. So for sentiment or the other use case that you told, I'm not aware, but I'll tell you in my use case what I've done. Okay, we are developing some system of memory for an agent, and in which like we are actually capturing something called a username. When he is conversating, maybe he might tell some kind of username. At the same time, the conversation classification. The conversation is related to some financial, or conversation is categorized into some something like maybe Swiggy ride pickup or something like that. Just I'm telling. Okay, so how these categories are changing in time? Okay, temporal change. Temporal change is one of the metric, volatility metric, and there is something called volatility metric. How your username changes. If you log in from a system, that means you have a user ID. So from the same user ID, if you start conversation, today I'll say Pavan, tomorrow I'll say Praveen, third day I'll say Bala. Possible, right? Okay, because I cannot put some kind of a mask or some kind of a cap on a user. Whatever he tells, that I have to accept. So we are measuring something called volatility. How volatile the name that is told by the user. If the volatility is too high, then there is a trigger saying that, okay, for this particular user, there is a too much of volatility that is coming in. The inverse rate of volatility is stability. Okay, we are computing 1 minus volatility, which is like stability. If the stability is too high, then we rely that person. Okay, and then maybe we'll take that data and then pass it back into some kind of workflows and all. If the volatility is too high, we'll not trust that data. We'll cut off that entire system. So these are some of the custom metrics that we are actually doing.
Interesting. Cool. Anybody else? Any other questions? Awesome. Okay. So I have a few other questions, but probably I'll reach out to you offline. It's already been 1.5 hours. Pavan, thank you so much. This was again like blinder of a session. Loved it. There is so much for at least for me to kind of like take away from this. We've recorded this. We'll post this video by Monday on our YouTube, and also please send across the GitHub link, the framework that you actually use.
Sure, definitely. But I'll just put a ping message inside WhatsApp. No, I'll send you the link there.
I will, like the VLAC and other things. I'll send all of those. Yeah, do share and we'll post it. Super. Thank you so much. Thanks for coming on a weekend and sharing this.
No issues. Anyhow, I'll read with even though I'm not coming here, I should read something. So good that I've interacted with you guys. Thank you guys, and then have a nice learning in Saturdays and Sundays. Bye.
Awesome. Happy weekend, folks. Thanks for joining. Bye.
Thank you.